in financial calculations such as compound interest, annuities, and etc. In algorithms, data sorting, searching, and optimization. In medical research to analyze genetic data and study biological sequences like DNA and protein structures. Sequences have various practical applications in our daily lives and in multiple fields. Twelve students in a class are each given a square card. The side length of each card is a whole number of centimeters from 1 to 12, and no two cards are the same size. Each student cuts his/her card into unit squares of side length 1 centimeter. The teacher challenges them to join all their unit squares edge to edge to form a single larger square without gaps. They find that this is impossible. We will explore the reason why creating a larger square is not feasible. Alice, one of the students, originally had a card of side length 1 centimeter. She says, if I don't use any of my squares, but everyone else uses their squares, then it is possible. Bob, another student, originally had a card of side length B centimeter. He says, me too. And I don't use any of my squares, but everyone else uses theirs, then it is possible. Assuming Alice and Bob are correct, what is a multiply B? Are you prepared to tackle this challenging question? Feel free to pause it, take a moment to brainstorm and solve it, and then continue watching the rest of the video. Hello, my friends. Today, we're going to tackle a 3-star lightning question. Let's dive in. First, one of the students has a square with a side length of 1. Since we can't cut it further based on the teacher's statement, we have only one item here. The second student possesses a 2 times 2 square, and we can cut it into 4 slices of 1 times 1 squares. The third student has a 3 times 3 square, allowing us to collect 9 slices of the smallest square by cutting it. Following this pattern, we can calculate for all the students. To collect all the squares, we need to sum all the unit squares. We can write 1 as 1 squared, 4 as 2 squared, and continue until we reach 12 squared. Assuming that you are already familiar with this formula. If you're not, it would be better to watch this video first. We have prepared this video to help you understand how this formula is derived. Now, 650 is not a perfect square. Because of this, they realized they couldn't make a larger square. So we should subtract a square number to reach another square number. Therefore, we can write these two equations through trial and error. The results indicate that one of the squares should have a side length of 5 centimeters, and the other should be 11 centimeters. That's it. We've found Alice and Bob's squares. Now, let's multiply them to answer this Olympiad question. The answer is 55. Well done, my friends. I hope you found this useful. Today's question is one of the most challenging mathematical Olympiad questions. Congratulations on taking on this challenge.